There are two concepts in mathematical logic. One is tautology and contradiction. What is tautology? If we have a compound proposition, say we have multiple statements, multiple propositions like P, Q, R and so on. If all the components of that particular proposition gives value as true, then it is called tautology. Say for example, right, we have P, Q and say some expression, something, for example. If all the truth combinations are true, 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 right, then this is called as tautology. Similarly, instead of all being truths, if it is false, then it's called as contradiction. So let's go over examples. So let's take an example. Let's see if this is going to be a tautology or not. So let's start writing the truth table. We have only two statements here, P and Q. P and Q. So we'll quickly write the truth values. True, true, P, F, F, T, F, F. Not P. Then we'll have to take this one. Then P or Q. Let's call this a second. So 1 or 2. And then let's call this as 3. 3 conditional Q. So what is negation of P? It's going to be false, false, true and true. P or Q. So in OR condition, if any one of them is true, then the final truth value is going to be true. So all this is going to be true. Only the last one where both of them are false, it's going to be as false. Then the next one is to take truth values for these two columns. Not P or Q. So we'll have to take these two columns. So again, in OR condition, only if both the statements are false, it's going to be false. So we don't have any case where both the statements are false. So everything is going to be true, true and true. Now let's take the next column where this expression we will have to apply conditional to Q. So we know in conditional truth table, only if P is true and Q is false, P tends to Q or P conditional Q is going to be false. Everything else is going to be true. So let's find this TF combination. We don't have TF combination anywhere. So everything else is going to be true in that case. So now looking at this column, all the values are true, which means this is a tautology. Let's take another example where we have to determine whether it is tautology, contradiction or it's neither. So let's take the statements P and Q and draw the chart, draw the truth table. True, 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 false, false, true, false, false. So we'll first take negation of Q, then we'll take P and negation of Q, then we'll find P and Q. So let's take this as column 1, column 2. We'll have to take column 1 conditional of column 2. So this is the final column. So negation of Q is going to be just the reverse. False, true, false, true. Now P and negation of Q. So we'll have to take P and negation of Q. So in AND we know that both the statements have to be true for the final truth value to be true. So do we see both trues here? Yeah, here there is true. So everything else is going to be false. Now we'll go to the second column, which is P and Q. Again for P and Q, both should be true for the final truth value to be true. So P and Q. So it's between these two, P and Q. Yeah, so this one is going to be true. Everything else is going to be false. Now the last column, it's between these two columns. We'll have to apply the conditional truth values. In conditional truth values, only if P is true and Q is false, P conditional Q is going to be false. So let's find for TF combinations. There's only one here. This is going to be false. Everything else is going to be true. So this is neither a contradiction nor a tautology. It is neither. Let's take another example. Let's determine if it's tautology, contradiction or neither. So P, Q, P and Q not P. Then we have P and Q and not P. So let's write the combinations. So P and Q. For P and Q, the final value is going to be true only if both are true. So only here it's going to be true. Everything else is going to be false. Negation of P. Just reverse it. Now we'll conjunct both of these columns. So P and Q and negation of P. So again, both the values should be true for the final value to be true. So we don't have any TT combination here. So everything is going to be false. So this is an example of, this is nothing but contradiction.